Okay, first time using this. Okay, it works. Hello everyone. It's really nice to see you. A lot of familiar faces in the audience, a lot of new ones as well. That's cool. Welcome. Today we are going to talk about memory management in Flutter. My name is Raitis. I'm a mobile iOS and Flutter developer at Chili Labs. I have made two Flutter apps myself, Kitchenette and OrbitGuard. OrbitGuard is actually a game. I played around with Flame game engine for that one. So if you haven't checked it out already, please do. Share your feedback and help me make this game go viral. Usually I play basketball, but I've been doing kickboxing for quite some time now. So be careful around me during the networking. I'm just kidding. Don't take me that seriously. Let's connect on social platforms. For example, Twitter. I'm not very active in terms of tweeting, but I'm trying to become more active day by day. So we'll see how that works out. Today's agenda. We'll talk about how can we tell that our app is leaking memory. What is actually a memory leak and what characteristics does it possess? What is the role of objects and references? Also, how is memory allocation and deallocation happening within our apps? What can we do to find the source of the memory leak? And what can we do to potentially avoid memory leaks in advance? So, okay. Can I ask you, please raise your hand if at any point, whenever you are using an app or developing an app or just testing an app, have you ever experienced performance deterioration of the app by experiencing frame drops or app freezes? Like, can you raise your hand if you have? Okay, cool. What about app crashes? Yeah, especially the ones with out-of-memory error in case of debugging the app. Let's just add one more, like increased battery consumption. For example, app is putting too much of a load on a processor, although it shouldn't. And in case you have experienced at least one of these problems within your app, chances are that your app was actually leaking memory. So what exactly is a memory leak? It's basically a condition whenever application fails to release unused memory so that it could be allocated for other resources. So is that the definition clear enough, or should we do like a practical sorts of example? Can you raise your hand if it's okay enough, or I don't believe you. So okay, let's do it like this. I want you to clap your hands, but don't release them. Like, put down your glasses and bottles, but just do it like this. Okay, memory gets allocated. If we want to clap again, we have to release our hands, right? Memory gets deallocated. Let's clap again. And this is where memory leaks happen. So in every good application, especially on the enterprise level, memory management is vital. Too soon? So when talking about, let me just check, I'm sorry. This is not going to work like this. Okay, so when talking about memory management in general, it happens during the runtime, mostly, and the memory that gets allocated and deallocated into the memory happens in the random access memory of the device, also known as RAM, right? Not to confuse memory leak with memory bloat, which actually is a condition whenever too much data gets, too much memory gets used for something. For example, loading too much data into the memory. Let's say we load a large image into the memory and never dispose of it afterwards. So basically, memory leak is like a gradual increase in memory consumption over time, but memory bloat is rapid, sudden increase in memory consumption. And then it just plateaus. So when talking about objects, we can separate out Dart-specific objects and Flutter objects. I guess, can you please, I'm sorry, but can you please raise your hands again? Who of you are Flutter developers? Okay, so I guess at least most of you should have heard by now that at least someone said that everything's a widget in Flutter, right? Which technically is not true, but sounds cool nevertheless. And when talking about objects in Dart, you can actually say that in Dart, everything is an object, because it is, apart from null, of course. So everything from strings, booleans, integers, to maps, lists, and so on, everything is an object in Dart in context of objects. The difference between Dart objects and Flutter objects is that Flutter objects come with their own unique set of characteristics. For example, a widget comes with the lifecycle methods. It's immutable, and it can be associated with other objects like state, which in fact is mutable, and so on, just as an example. So we can divide objects into two categories based on their lifespan within the app. There are short-lived objects and long-lived objects. Short-lived objects are created and destroyed frequently, and they can be anything from local variables that are defined within the scope of the functions, also UI state, iterators, and so on. Long-lived objects, on the other hand, are garbage collected less often because they persist in the app for longer periods of time, and usually they are global variables, app state, controllers, and even cached objects. Okay, let's talk a little bit about object references. So, with every Dart application, a root object gets created. And it references every other object that gets allocated into the memory. So, and since root object is the entry point of garbage collection, okay. I'll just leave it open, I guess. Okay, so root object is the entry point of garbage collection, so that it, based on references, it can, like the garbage collector can understand which objects it can collect and deallocate the memory, release the memory. Okay, so the references between, okay, so something's not quite right with this one. What is the next slide? Okay, what did I miss? Okay, let's do it. Let's do it this way. So, what is retaining path? it's basically a sequence between, it's a sequence that is formed by references that are pointing from one object to another. There are reachable objects and unreachable objects. Reachable object is an object that has at least one reference pointing to it, which means that it's currently considered to be in use by the app. Also, it's seen to be in use like by garbage collector, and that is the reason why it cannot be garbage collected. Reachable objects become unreachable when there are no more references left to them. So basically, unreachable object is not used anymore, and it's eligible for garbage collection. So, okay, about memory allocation. Okay. Sorry. Yeah, so memory allocation is basically a process of assigning portions of virtual memory to executable program. In other words, it means that application needs memory to be able to execute its commands, do some calculations, also store and manage some data. When talking about memory allocation, we can divide it in two categories, like static memory allocation and dynamic memory allocation. Static memory allocation happens during the compile time, meaning that all the objects that are created must be of, no, not must be, but they are fixed size, meaning that they cannot be changed during the runtime. And mostly constants and static variables are the ones that are allocated statically. Dynamic allocation, on the other hand, happens on the go during the runtime of the application. It sort of adds flexibility in terms of memory allocation because of in terms of size, and the objects are allocated only when it's actually required. So, since Dart is a garbage collected language, its runtime comes with garbage collector. Garbage collector essentially garbage collector essentially just makes sure that so garbage collector essentially just identifies which objects are no longer reachable, and like releases the memory from them and keeps it available for any future allocations. And garbage collector, being the automatic memory manager, means that developers do not specifically need to write memory management tasks, at least not in traditional sense. You don't need to write the code to manage memory specifically when it comes in terms of in context of garbage collector. In terms of garbage collector. So you can basically look at garbage collector as your sidekick, as a behind-the-scenes hero who cleans up after you and always, well, almost always has your back. If you want to know more about garbage collection, I highly recommend checking out this talk by Anna Lushenko. It's she basically covers everything, the ins and outs of garbage collection. It's very insightful, very detailed, and very well illustrated. Okay, so dynamically allocated memory is stored in Dart's heap. It's operated by the operating system, which means that its size is limited to the size of virtual memory. And whenever memory overflow happens within the heap, memory leak occurs. And it's also the memory of the heap is managed by Dart virtual machine, which means that it's allocated on the creation when the app is loaded, and released when it's no longer of use. Okay. So, what can we do to find out the source of the leak? Well, we could use tools provided by debugging tools provided by Flutter and Dart team, specifically DevTools Memory View and Leak Tracker package. Leak Tracker package is relatively fresh. I would say it's still pretty much in development. But yeah, let's take okay, so I guess White Ninja says that we need to do something, so let's quickly do something. Whoop, you shouldn't have seen that, but I guess it's okay, just my notes. So what we have here is, I hope, can everyone from the last row can see it? Okay, it's cool. So this is DevTools started up in a browser. And what we are interested in is specifically memory section. One thing to mention, to point out, is that I'm running this app in debug mode for the purposes of the demo. But if you want the most accurate readings, you should always test it in profile or release mode. So what can we see here? Let me just pull this a bit down. Can you make this bigger? I guess not. So there's this graph timeline of, this is basically a memory chart. What can we see here is resident set size. For example, it's the memory that is loaded, that is available for immediate use. This orange dashed line, and what we will focus on is the blue wave, like the size on the heap, memory size on the heap. Yeah, the tabs that we are interested in is profile memory, also diff snapshots, but I won't cover this today. Trace instance and detect leaks. Detect leaks is only available through Leak Tracker package. And it basically tracks leaks within your app and the most common leak types, the ones that are not disposed, not garbage collected, or they are garbage collected late. So, little backstory of the sample app. There's a leaking container which will be removed from the widget tree and inserted back into the widget tree when tapping on the toggle container button, the red one. Underneath, it uses a text editing controller, which is not properly disposed of. And when pressing the blue button, increase leaking objects, we are going to generate 10 million objects and store them in a list of a singleton object. Okay, let's try this out. Hopefully it will work. So if we do this a couple of times, we can see that our app is leaking memory. As you can see, 4 memory leaks identified, none of them were disposed. And what we can do is download this and analyze the stack trace of our leaks. If it will open, yes. So as we can see here, total of 4 not disposed objects. text editing controller. As I said, identity hash code, not really useful for us, at least not for today. And if we look carefully at the stack trace, it's pretty huge actually. But since I know the name of my widgets, I can easily spot it here. And so basically, it tells us where that leak is kind of coming from. And so this is about leak tracker package. Now we can go back to memory profile, to profile memory. So what we want to do here is look for unusual amount of instances and total size created. So let's see if this works as it should. As you can see, there are like many leak objects, instances of leak object. They take up more than 120 megabytes. And yeah, we have 10 million instances of leak object generated. What we can do here is, obviously we could search it in our code, but from the DevTools, we can go here, like filter out leak object, find it here, check the checkbox, say that we want to track it, select it, and when the next event is fired, it should return the code path. If everything, yeah, as you can see, we can see here the code path. In my case, it's not very long because, as you can see, it just returns unincreased leaking object. That's the method where this is happening. So yeah, that's basically how we can start at least locating our leaking memory. Just try to find the culprit and potentially fix it. Let's try to crash it real quick. Okay, maybe it's not going to crash. Probably it will though, but it's going to be in the background. Okay, let's return to this, the presentation. I came prepared with the backup option 1, backup option 2. Okay, so we're finally here. What can we do to optimize our memory? To optimize our memory, there are like several techniques and methods. What we can do to potentially at least limit the chances of memory leaks. Okay, first one, we could try to use weak reference. What weak reference does, it creates a reference that allows, it allows for the object to be garbage collected even it has reference pointing to it. And how it works, basically you wrap any regular object that you would create normally with a normal reference within the weak reference class, and just basically use it. One thing to mention is that you need to probably add some additional checks because the target of the weak reference can be null. And another thing is that probably you won't use it in a widget, for example, that gets rebuilt very often or at all, because at any point garbage collector can just collect this object and release it from the memory. So you have to be very careful with this one. We could also lazily initialize our objects, for example, with factory constructor, also getters, or even late initializer. using late initializer keywords. All of these basically boil down to the fact that they're all initialized only when it's necessary. And yeah, and these instances in these cases are created only once. Why not use mixins? For example, if you're dealing with, let's say, change notifiers like text editing controllers very often within your app, like you have many screens where you have to use them, and why not create a mixin that actually handles the disposal of these objects instead of doing it manually inside each stateful widget. Again, need to mention that it will mostly always depend on your implementation of your needs within the app, whether or not it makes sense for you. I guess it's up for you to decide, but that's, in my opinion, this is one of the techniques that you can get creative with most if you decide to actually try it out. The obvious one, you need to discard of the resources used by the object in dispose method of, for example, stateful widget. As you can see in the code snippet, you have to dispose of the text editing controller. You can cancel subscriptions, close syncs, and so on. This is manual work, but it's highly effective, so you just have to be aware of it, not to forget to do it. Yeah, using const constructor. So use const constructor whenever and whenever possible. Why? Because, well, first of all, constants get allocated during the compile time, which is a recommended optimization and also performance gain. And secondly, whenever you create two identical instances with a const constructor, it will actually create one instance and reference the others. For example, if I create like speaker 3, and it's again like the same constant, it will actually reference the first one that was created. Okay, so you have two examples in front of you. The left one, to your left, pure Dart, and on the right, your right again, with Flutter widgets. So I want you to raise your hand if you think in the first case, on the left side, it will print out true. I guess you didn't understand the question. So what's going on in the print method is we are comparing if the object speaker 1 is identical to speaker 2. So can you raise your hands again if you think it will print out true? Okay, not what I expected, but it will work. Yeah, it will print out true. So what about example on your right side? I want you to raise hand if you think those two objects are also identical, if it will return true. Can you raise your hands? Okay, tough crowd, I guess. But it returns false, so like you're probably thinking like, what is this guy on about? Like, how it can be, they're like literally the same object. You can see, you can compare the characters, like size box, like what's happening? So the thing is that in debug mode, the const canonicalization happens differently than it does in release mode. And this is because of the added support for debugging tools in debug mode. So in release mode, it will actually return true. Release mode, I said that, yeah. So it will actually return true. And the thing is, you don't have to worry about it because in debug mode, still the const canonicalization is performant enough and you still get all the gains all the performance gains from it. On the other hand, const canonicalization. So this is specific to widget widget constant canonicalization. With regular constants, it works well in either build mode. So, well, a few minutes back, we checked out leak tracker and the most common leak types that it tracks. So the fixes for them are fairly simple if you are able to locate the source of the leak. So for objects that are not disposed but they were garbage collected, all you need to do is call the dispose method on the object. As I said previously, it can also be close or cancel for different objects. And for objects that were disposed but not garbage collected, or for whatever reason they were garbage collected later than they should have been, you need to assign reachable objects reference to null after disposing of the object. So let's do a quick recap of what we discussed today. When does the memory leak happen? Whenever app fails to release the unused memory and make it available for any future allocations. What is a reachable object? It's an object that has at least one reference pointing to it, meaning that it's still in use and it cannot be garbage collected. What is an unreachable object? It's the opposite of reachable object, and it holds 0 references and it can be garbage collected. What can we do to detect the source of the leak? There are like few options. Either you're a complete code wizard and you can just open the code, look at it and say, okay, this is where it's leaking, then great for you. But for me, it's easier to use debugging tools provided by Flutter and Dart teams, like DevTools Memory View in combination with Leak Tracker package. And what can we do to potentially prevent those leaks? There are various memory optimization methods. These are just a few of them that we looked at today. But the most important ones probably are proper resource disposal within the stateful objects and using const constructor whenever possible. Yeah, you can, if you want, you can search for my apps on either App Store or Google Play. Thank you for listening. Yeah, I hope you learned something. If not, maybe you brushed off the dust on some forgotten concepts. Let's talk afterwards if you are interested in something that I said. But thank you. Yeah.
Thank you, Raitis. Do we have any questions for Raitis? Put your hands up.
Can I run these on the CI in a headless emulator, this memory catalyzer?
No, unfortunately, you need a real device for this one.
Okay.
Yeah.
So I'm a Flutter developer, so I know about the dispose stuff. It's like pretty typical stuff that's common in state. But I was wondering about how you caused the leak of the large objects in your example.
Just by generating basically a large number of, basically it generates 10 million integers and creates an object. Like the basic class, it creates an object and stores it in a list of a singleton object. And in this particular example, it never gets disposed of. So, or
okay, but the list still lives somewhere, so they basically still have a reference somewhere, which is like a leak per se.
I'm not sure I understand the question, but can you maybe try to explain in other words? But
I'm mostly familiar with leaks from like languages that don't have garbage collectors. So when we talk about leaks in garbage collector languages, it's already quite surprising to me. I was just wondering whether there was some nuance in Dart code which can actually accidentally cause a leak in the sense that this object is actually like somewhere in the ether and you will never be able to dispose of it again.
I mean,
but it seems like that's not the case. It's mostly just the leak tracker helps you find places where you have accidentally not released the object.
Yeah, basically yes, but we didn't use leak tracker specifically to track leaks for instances that were created with the blue button that generates the large list of the objects. But yeah, this is basically an example to illustrate that how leaks would normally happen. I guess I could actually upload the code as a GIS to my GitHub page later on, and you can maybe check it out yourself if you're interested. So, yeah.
Yeah, I understood the concept now. It just wasn't clear at the end of the day.
Okay.
Okay, any more questions? If not, then you can catch Raitis in the networking space. And thank you, Raitis, very much.